One of the core building blocks of programming is sorting algorithms. Many programs require data to be sorted, and many programming languages don't offer an easy way to do this, or if they do, it's very slow. Uh, Today, we're going to take a look at one type of sorting algorithm called bubble sort. Bubble sort is a very rudimentary sorting algorithm, but it's very easy to comprehend and understand what's going on. It may be a little slow, but it gets the job done, and it's a very good entry to sorting algorithms. So let's take a look at bubble sort and dive into how it works and where we could use it at. So if we take a look over here at VS Code, I've just got a empty JavaScript file called bubble sort. Um, so the way that bubble sort's going to work is we're going to write a function that takes in an array. All right, and this array can be completely unsorted. And it's going to at the end return a sorted version of that array. So we will take in that function, and the way bubble sort is going to handle it is we're going to create two separate loops. One outer loop that's going to loop all the way from the end of the array to the beginning of the array, and an inner loop that's going to loop through from the beginning of the array to the end of the array. Now, the reason for both loops looping the opposite direction of each other is because of the nature of bubble sort. Bubble sort works by bubbling up the largest values and all the way up to the top. So bubble sort will check to see if one value is greater than another, and if it is, we're going to swap them. So let's take a look at how we're going to do this. So we're going to create a function, and my F key is still not working. Function, and we're going to call it bubble sort. All right, and now this function is going to take in a value called ARR for the array. Now, at the end of this function, we are going to return the array. At that point, it should be sorted. Let me just grab here our data set. Now, this is just a standard unsorted array. And this is going to be what we pass into the bubble sort function that is going to be return sorted at the end. All right, so we need to create our outer loop. So we're going to say let I equal array dot length. All right, and it's going to start at array dot length minus 1 because like I said before, bubble sort is going to start here and it's work its way down on the outer loop. And basically the inner loop, we're going to loop up until where I is. So let's take a look at that. So our outer loop is going to say while I is greater than 0, while I is greater than 0, then we're going to do I minus minus for a decrementer operator. All right, and then inside of this loop, we're going to create another loop. This loop is going to loop from the beginning of the array all the way up to the end. Or I'm sorry, not the end, but it's going to loop up all the way up until where I is. All right, so the way that we're going to write that is we're going to say let j equal 0. All right, we're going to start the loop at the beginning right here. Now this is going to be what checks to see if the value should be swapped or not. So we're going to say let j equal 0, and we're going to say while j is less than or equal to I minus 1, because remember, I should already be sorted. So, or I'm sorry, I should not already be sorted, but everything after I should be sorted. All right. So then we're going to do j plus plus. That's just our incrementer operator. Now we're going to check if array at index j, all right, is greater than array at index j plus 1, all right, and it's going to check basically, so the first time through I is going to be here, all right, and then it's going to j is going to start here, and it's going to check is array at j, which is here, greater than this value. And it's going to, and for this first example, 1, it's going to say is 1 greater than 22, and it's going to say no, that's not true. So it's going to skip this first iteration, all right, because 1 is not greater than 22, all right. But then it's going to increment, so j is now going to equal 1. So it's going to look at j here, and it's going to say is j greater than j plus 1, which is 5. So it's going to say is 22 greater than 5, and it's going to say yes, that is true, and then it's going to initiate this if loop, or this if statement. So inside of this if statement, we need to a way to swap these values in this array. Now, the easiest way to do this is to write a swap function, and I will show you how to do that here in just a second. I'm just going to write we'll write the swap function here in just a second, but so this swap function is going to take in the array, the entire array, because it needs to be able to access that array inside of that swap function. So it's going to take in as its first argument array. All right. Its second argument is going to be the current position of j. All right. Now j is just a value. It's just a value like 1, 2, 3, 4. It's not the current value at that index. It's just the index. So then it's also going to take in the swap index, the index that we want to swap it with. So this will make sense, a little bit more sense here in just a second. So we're going to say j plus 1. So whatever value is in j is going to be passed in. So if our j value is currently 1 right here, this 22, all right, it's going to take in that index of 1, all right, and then it's also going to take in j plus 1, which is the next index, where we want to swap this index with that index. All right. So once we swap the values, they'll be swapped. So basically, I'm going to write a swap function here, and I'm just going to start it up here. It's going to be function swap. All right, it's going to take in that array, and I'm just going to call it data here. All right, and actually, I'm going to create this outside of this function. It doesn't really matter, truthfully, but I like to try to not nest functions if possible. At least function definitions. So we're going to define this function here at the top. All right. And there's two different ways we could do this. There's an ES 2015 syntax, and there's the earlier version. I'm going to write the earlier version, and then I'll throw in the ES 2015 syntax version. I feel like the older version is a lot more common, and it is a lot easier to understand at first glance. But this swap function is going to take in the data, which is going to be the array that we're passing in here, the whole array. All right. I'm actually going to call this array. I lied. And then it's going to take in that first index, which is j. So we're going to call it indx1. All right. and is also going to take in the second index that we're swapping with, so indx2. All right. Now, first thing we need to do, because the nature of arrays, we need to create a temp variable. This temp variable is just going to store the value. It's exactly what it sounds like. It's a temporary variable that's going to store a value until it's no longer needed. So we're going to say let temp equal, and we're going to check array at index 1. All right. So now the value of index 1, actually the value at array index 1 is going to be stored in temp. All right. Now we're going to say we're going to reassign array at index 1 to the values currently stored in array at index 2, or index 2. All right, so we've defined this temp variable, and it's currently storing the value. So if we look at the values down here, it's going to be storing 22 because that's the one that we passed in at array index 1. All right, and then we're going to be reassigning array index 1 to whatever the value is at array index 2. And I remember we passed in j plus 1 as index 2. So index 2 is going to be the value 5. So once we run this here, it is going to make index 1 the same value as index 2. So now the array is going to look like this. All right. So that's why we needed the temp variable, because we couldn't update both at the same time, at least with this method. Now, what we need to do is grab array at index 2. All right. We need to save that equal to whatever value is stored in the temp variable. So now that temp variable that was saved before this reassignment is now going to be set equal to the temp to index 2. Now we're done with that temp variable. So if I just change this back to 22, now let me save this here. All right, and for the most part, this is already done. We can actually run this code. If we run this and we say node and we say bubble sort, all right, you can see it's sorted the array. Now, it seemed fast, but it really took a lot longer than it should have. Bubble sort and other a couple other of the rudimentary sorting algorithms, they're better with smaller data sets, and there's a small feature that we can add. I wouldn't say a feature, but there's a small advantage we can take advantage of with bubble sort to check to see if we can be done with this early, because the code doesn't know if all of this is sorted or not. It's just going to continue to run until it says stop here. All right. So let's take a look at a simple trick we can implement to make this run just a little bit faster. So the way that this speed up little trick works is it takes advantage of bubble sort and how it loops through the values. What I mean by that is if we go through here and we're looping through each one of these values, and we can check to see if we swapped a value in that loop. So what I mean by that is if we go up to 22 here and we have to swap with 5, we can define a variable, and whenever this is called, we can change that to be false. So let me write it out here. It might make a little bit more sense. So for this, we're gonna say we're just gonna define a variable called no swaps. All right, and this variable is going to hold a true or false value. All right, now remember this outer loop here. This outer loop here is looping through from here down all the way to the end. All right, and then this inner loop here is looping from here all the way to here. Now remember, we're checking every single value every time for every loop iteration of this. So we can say if we get through this with not a single swap whatsoever, so we never had to call the swap function, we can assume that that array is already sorted, and we can break out of that loop early. So when we're looping through, if we go through the entire loop, and then we start back over here at the beginning again, and we go through the entire loop again, if we don't swap any values, we can say that that this here is sorted, because if remember, we're checking to see if this value is greater than this value. So if it's already sorted, the first value will never be greater than the second value. All right, so the way this works is we will loop through here, and then we'll go back up to this loop, and we're gonna set no swaps. We're gonna say is true. We're just going to assume that there's not going to be any swaps. And if there is a swap inside of this if statement, now remember, this only runs if the current value of j is greater than the next value of j. So here in the case of 22 and 5, 22 is greater than 5. So this will only run in that scenario, but in this scenario, 1 is not greater than 22. This will never run. So if this does run, that means we had a swap. So we're going to set no swaps equal to false. All right. So then, if no swaps is false, that means we did have a swap. So down here, after the inner loop, we can check if no swaps is true. And if no swaps is true, meaning we didn't have to swap any values whatsoever in that last iteration, that means that the array, the data, is sorted, and we can break out of that outer loop. All right, and we can end that thing early. So that saves us a little bit of time. Best case scenario, the array is nearly sorted, and we only have to make a couple iterations before we encounter this to be true. So if we save this here and we run this code again, we'll see it still works. And you can't see it right now, but it did actually work. To help illustrate the different sorting algorithms and the different ways that these sorting algorithms work, there's this site. I'll leave it linked in the description. There's this site that shows all of these different sorting algorithms and how they work with different types of data. So we've got random data that is just completely random, the same random data that we have in our data set. And then there's nearly sorted data, data that's almost sorted but not quite yet. Um, and then we've got reverse data, data that's completely backwards. So let's take a look at the completely random data and see how these sorting algorithms work. Now you can see bubble sort right here. And it looks like bubble sort's kind of struggling a little bit there. Towards the end, it kind of sped up a bit. But if we take a look at that again, completely random, see how it's going through every single one of them from the end all the way to from the end all the way to the beginning. And if we take a look at something like merge sort here, it goes much quicker than something like bubble sort. But if we take a look at nearly sorted data, take a look at bubble sort's already done. All right. If we play that again, we look, bubble sort's completely done already, and even some of the quicker algorithms over here, like merge sort and quick sort, fall behind on nearly sorted data. So there are use cases for many of these different algorithms, but unless you know for a fact that your data is going to be nearly sorted every single time, bubble sort is probably not going to be the best case scenario for you to implement it. So that is the conclusion to bubble sort. The only thing I have left, I told you I would show you the ES 2015 syntax of this swap function. It's a little bit, once you understand how it works, it's a lot easier to understand and a lot more compact. But it's a lot less easy to understand at first glance. So let's just define this function, all right? And I'm just going to comment this out here because we're just going to call this function swap as well. And it's going to be the exact same thing. It's going to take in an array. It's going to take the index 1 and it's going to take the index 2. All right. Now this is the 2015 version of the newer version of array manipulation. So basically, this is how we're going to do it. Array of index 1, all right. Array of index 2, and we're going to set that whole thing equal to array of index 2, array index 1. All right, and that's it. That's our swap function. So if we save that, we run the code down here again, we get the same result. All right. Now this works by taking advantage of what is called destructuring assignment. So basically the way that this works is it's destructuring these two values into these two values. So there's whatever JavaScript does in the background, it basically just assigns the values of these to the values of these. All right, so that is the conclusion of bubble sort. I hope you learned something new. If you have any questions, post them in the comments for me. I will try to answer as many questions as everybody has. I hope this makes things a little bit more clear on how bubble sort works. So thank you all for watching. I hope you learned something new, and I will see you in the next one.